Sabah, Malaysian Borneo, the third largest island in the world.
Oh, saya kenal. Welcome back to the first parallel session of the second day of ICECON 2024. For your information, this session will focus on structural and material engineering papers. Sweet reminder to all presenters, each presenter is allocated with 20 minutes to present your paper, where 15 minutes will be the session for you to present your paper, and the other 5 minutes is the question and answer session. For that, I am delighted to invite Engineer Amirul Hisham Haji Ismail from the Association of Consulting Engineer Malaysia as our chairperson, and Engineer Dr. Nelly Majain, chairperson for the topic Structural and Material Engineering. Please give a warm welcome.
Assalamualaikum and very good morning to everyone. Can you hear me?
Yes, I can hear you.
Okay, thank you. A very warm welcome to all participants in today's parallel session prior for the third International Conference of Civil Engineering and Construction Technology 2024. So the next paper that's going to be presented today is in regard of the S08 annealing environment dependence of solution immersion grown nickel oxide nanoflowers, presented by authored by N. Paramon, MH Mahmat, MF Malik, and MNA Uda. Right? So I think I get it all right. I believe this paper will be presented through video presentation. Am I right?
Live presentation, IR.
Oh, live presentation. Okay. So without further ado, I would like to invite our honored presenter to present her paper on this subject. Please, thank you.
Hello, Assalamualaikum. Can you hear me?
Yes, I can hear you. No problem.
But my voice has echo. Sorry, I just unshut again. Um, okay, can you see my slide?
Yes, I can. Thank you.
Thank you, Mr. Chairperson, IR Amirul. Yeah, okay. Okay, my name is Nafara Rianti binti Palimon. I'm from Center of Research in Energy and Advanced Material CREAM, Faculty of Engineering, UMS. Okay, today I would like to share my preliminary result of my research, the topic entitled of Energy Environment Independence of Solution Immersion Growing Nickel Oxide Nanoflowers. Okay, so when we are talking about the nano device, okay, in terms of nano device, okay, it's come from the nanomaterials and nanostructures itself. Okay, so various nanostructures of metal oxide can be formed by a variety of synthesis of techniques. Okay, so we have zero-dimensional, such as nanoparticle, quantum dots. Okay, we have one-dimensional, such as we name it as a nanowires, nanorod, and etc. Okay, two-dimensional and also three-dimensional. Okay, and this is a nanoflowers. Okay, in three-dimensional form. Okay, so during the deposition of the metal oxide based film, okay, so metal oxide can be film based or powder based. Okay, is deficiencies in terms of oxidation and impurities might be occurred. Okay, so after the deposition of metal oxide, we have to anneal or calcine the sample. Okay, so the post annealing hot or heat treatment to a specific temperature is the common procedure that can influence the nature of the nanostructures and further enhance their properties in terms of morphological, structural, optical, electrical, mechanical, and as well. Okay, so normally the heat treatment or post annealing, the sample using the different annealing temperature, but we suggest to diversify the annealing treatment to these metal oxide nanostructures in different environment using argon and ambient atmosphere. Okay, so metal oxide consists of p-type and n-type metal oxide. Okay, so one of the p-type metal oxide, okay, nickel oxide is has been extensively studied. It has a wide band gap ranging from 3.6 to 4.0 electron volt. Okay, and then it widely used in many branches of application. Okay, such as sensors, electrochromic devices, solar cell, LED and batteries because of the its high thermal stability, the excellent in terms of chemical stability, okay, the electrical conductivity, the transparency, and also high surface to volume ratio. Okay, so by providing the argon as an isolated ambient gas in this post-annealing process, the hypothesis it can the contaminant could be removed, and the crystal defect coming from the external ambient can be eliminated. Okay, as such, the conductivity and the transparency of the film could be improved, and the resistive properties could be also lowered. Okay, and then it make a certain device application more stable and efficient. So accordingly to these 3D nickel oxide nanoflowers, we prepared using the solution immersion method as the main method, and we anneal the sample in ambient and argon environment at 500 degrees C. Okay, and then we investigate the influence on its structural and optical properties. Okay, okay, this is the first step of deposition of nickel oxide nanostructures, but we deposit the nickel oxide seed layer first before we grow the nickel oxide nano flowers. Okay, so we use soil gel spin coating as the seed layer, or we call it as a thin film. Okay, to improve the adhesion of nickel oxide nanoflowers. So first step is using soil gel spin coating. We mix the solution using nickel acetate, diethylamine, and ethylene glycol monoethyl ether, and then we start an aging process and go through the spin coating process for 5 layers, and we try and the annealing process. Okay, this is using the ambient common ambient environment. Okay, and then the nickel oxide seed layer or thin film will be formed on top of the glass substrate. Okay, previously we used the ITO, which is the indium tin oxide coated glass substrate, but we use this time we use the seed layer to improve the adhesion of nanoflowers. Okay, so and then the second step is using the immersion method. Okay, the solution preparation using nickel nitrate, HMT, and deionized water, and we go through the sonication process, stirring, and the immersion process is at 95 degrees C for 2 hours. Okay, in a water bath. And then drying process at 150 degrees C, and the crucial part is the sample will anneal in the CVD, chemical vapor deposition, and the furnace. Okay, so the argon environment, we anneal or calcine in the chemical vapor deposition, and with the ambient atmosphere, we anneal sample in the common furnace. The annealing temperature is 500 degrees C for 1 hour. Okay, for the characterization of the two samples, okay, we just focus on the structural analysis and optical characterization. So maybe further improvement or characterization need to be done. Other than the structural and optical. So for the structural, we analyze using FESAM and XRD, and then the optical characterization is using UVV spectrophotometer. Okay, for the structural morphological, using FESAM characterization. Okay, from the figure, okay, we can see both sample, okay, anneal in argon and ambient. Okay, they have a bouquet of rounded flowers. Okay, and then the shape and pattern with thin petals. Okay, but we can see the image anneal in the argon environment has more prominent petals and porous than the sample anneal in the ambient environment. So from the EDX, we can see this EDX sample for argon environment. Okay, we can see the well-defined two peaks for nickel and oxygen, and then another two lower peak, which is silicon and argon. Okay, silicon is from glass substrate. Okay, and then the argon is from the annealing environment. Okay, for the structural in terms of the XRD diffraction pattern, we can see that the both sample display polycrystalline structures which can be indexed to the cubic pentanickel oxide. And then both sample has three prominent diffraction peaks at 111, 200, and 220, while two infirm diffraction peak at 311 and 222. Okay, and then we can see we can observe that from the two diffraction peak, the use of argon, okay, the intensity of the peak could be higher. Okay, and then it can be enhanced the crystallinity of the sample. Okay, Okay, and then we calculate the crystallite size of the AH sample. Okay, and then we get the average of crystallite size. We can see both sample is more or less the same, the size, okay, with the argon annual nickel oxide sample being slightly higher, lah, 19.4. Okay, we use the Derbyshire equation to calculate the crystallite size. And then in terms of dislocation density, for three prominent peaks, which is only 3 peaks. Okay, we calculate it shows the same trend. Okay, the argon slightly higher than the ambient. Okay, so the higher dislocation density, the higher distortion in the atomic arrangement, which can imply a high degree of defectiveness. Okay, so the defectiveness in can be positive or negative, but in terms of positive, so it can sometimes enhance the electrical and thermal conductivity of the material. Okay, as I said earlier, we have to improve. The characterization with others, let's say for the electrical measurement to know which better from the result. Okay. Okay, for the optical properties, we measure the transmittance and absorbance of the samples. Okay, from the transmittance plotting, we can see the argon annual sample higher, the transmittance higher than the ambient atmosphere, which 37% and 32%. Okay, the transparency is slightly higher lah in the argon atmosphere. So maybe in the variation of the thickness of the nanoflower cause the transmittance difference. Okay, but both sample the transparency is lower than 50%. Okay, so for the absorbance, we can see from the argon, the absorbent age is below 410 nanometer, but for ambient atmosphere, it's lower than 360 nanometer for the absorbent age. And then we can estimate the optical band gap for the sample ambient annual is larger than the band gap of the argon annual sample. For the conclusion, we successful deposit grows the nickel oxide nanoflowers using immersion method, and then we studied the annealing environment between ambient and argon. Okay, and then we can see the surface morphological core sample. Okay, for argon is more prominent and porous than the ambient atmosphere. And from the XRD and optical properties, nickel oxide anneal in the argon environment exhibit improved crystallinity and higher transparency. And higher crystallite size was produced in the argon atmosphere. Okay, will generating a higher density of defect. Okay, so both sample anneal in different environment have comparable structural and morphological characteristic. Okay, and then we can maybe apply for this sample for possible application in photovoltaic devices, sensors, and electrochromic devices. Okay, in other than argon, we can suggest to anneal the sample in nitrogen and oxygen atmosphere. Okay, to see the difference in terms of their properties. Okay, with that, thank you. That's all from me. Thank you.
Okay, thank you very much, Dr. Norfara. So I think whether we have to open it for any questions and answer, because I just completed a 15 minutes presentation. So if we have any questions from the floor in regard of this paper.
Hi, good morning. Dr. Andrew here from UMS. Can I ask a quick question?
Yes, please.
Okay, all right, okay. Yeah, for some reason I can't hear myself. Okay, right. Morning, Dr. Parimon. Hi. So just a quick question because later on in my presentation, I'm also going to be touching on XRD as well. Yeah. So this question is not related directly to your research per se. So I'm just wondering because you've done the XRD test. So first question is, where did you do it? Is it at PIPS? If yes, then how did you actually do the analysis? Because obviously you don't have access to the software, right? The XRD software. Did they do the analysis and give you the Excel chart and you have to analyze and then, or how did it happen? Yeah, the XRD.
First question is where I did the measurement.
Yeah, XRD.
Uh,
Yeah,
You mean that the place where I did the
yeah, that's right. Whose equipment? Yeah,
okay. The equipment is using as I mentioned in the slide, okay, using an analytical expert pro. I measure it and in UiTM Shah Alam.
okay.
Yeah,
Yeah.
and then I got the raw material, raw data, and then I just plotting by myself lah, sendiri.
Oh, okay.
Then
Which software did you use out of interest?
origin,
Origin.
yeah.
Okay. I use Origin as well, but Origin doesn't actually help you to detect the materials, right?
So
It's
far
more like
it can
numerical
automatically plotting and then show the peaks that
yeah, correct.
detect from your sample. But
Oh,
if you want to further explanation from me, you can contact me. I can assist you on the
okay.
SRD.
Okay, thank you. All right.
Okay.
That's it from me. Yeah, thank you.
Thank you, Mr. Lim. Okay, any other questions from the floor? We still have about 2 or 3 minutes left in the Q&A. Maybe I have one question, Dr. Novara. Despite I'm not a material engineer with any chemical engineering background, I'm quite inquisitive when you said about the sonication. The process of sonication means you actually vibrating or sending sonic wave to the material, which can change the character or behavior of your substance. Am I right?
Yeah. Okay.
Okay. So is it the only way to alter the behavior of your material? The sonic. To what extent the sonication can actually alter the behavior of your material? Is it like 20%, 30%, or so on, based on your study on this particular nickel oxide? So maybe
So far, for this sample IR, we produce to for the application of the sensors. So for the sensors, the morphological or the structure, the nano structures, must be porous. The porosity must be higher, so that the absorption and desorption process during the sensors process will be it can detect the sensitivity highest lah. Okay, so if we can we didn't do the sonication process. Okay, I can see the sample or the morphological is not really porous, so it's not help in terms of the higher sensitivity of the sensors. So during the sonication, the atomic is apa? Belanggar macam mana? Dia macam disperse the atomic tu. And then it can help the porosity of the structures of the a sample, and then the sensitivity of the sensors could be higher lah, with the assisting of from the sonication process. Okay, so we have prepared two sample with sonication and without sonication. We can see the difference of the morphological structures.
All right, thank you, Doctor. Any other question from the floor? I think we'll have about 1 minute, maybe one more question. So if there is none, I think we can end this session with Dr. Nurfara on her paper. We thank her for giving us a very knowledgeable input on the subject matter, and hope it will be beneficial for all the listener out there. Okay, so I think I will return this back to the host for the next subject to be presented.
Good morning, Chairman, and good morning. It's my presentation video because I'm in China. So I prepared a video for my presentation. Okay.
Okay, thank you.
Dear Chairman, doctors, ladies and gentlemen, good morning. I'm Nick Tian, a lecturer from Hebei University of Engineering, China, and a PhD from University Malaysia Sabah. It's a great honor to attend ICECON 2024 and present my study at the conference. My research interests are solid waste resources utilization, green building materials, and cement-based cementitious materials. Today, my presentation is entitled Study on the Performance and Hydration Mechanism of Hybrid Activation of Vanadium Titanium RO tilings. This is content. Introduction. Vanadium Titanium RO tilings, VTLT, formed during the beneficiation of vanadium titanium magnetite, are low silica silicate minerals tilings. Its stockpile is huge, not only occupies land and damages the ecological environment, but also seriously wastes mineral resources. Replacement of ordinary silicate cement by activating tailings to exert its binder effect have been extensively studied in the past decades. Currently, the main activation methods include mechanical, chemical, thermal, and various combinations. At present, the activation process of VTLT is limited to a single activation method, and more than 2 or 3 activation methods have not been reported. In my study on the basis of the best active tailings powder obtained from mechanical activation of VTLT, activity index is 75%. We further adopt the hybrid activation technologies of thermal activation or chemical activation to study the effect of calcination temperature on the physical and chemical properties and activity of index of VTLT, and the effect of type of and amount of activators on the activity and hydration mechanism of VTLT, with the aim of enhancing the potential of the sustainable utilization of VTLT as mineral admixture in replacement of cement and to support the research and application of green and low carbon building materials. Second, experimental materials, VTLT, IOS-SUN, reference cement, tap water, DEPIA, SS, CS, FGDJ. Third, experiment method, VTLT powder in the Marfil furnace calcination. The temperature was set to 550 degree to 950 degree, holding 2 hours. The FGDJ was calcined at 800 degree, holding 2 hours. CS was calcined at 850 degree, holding 2 hours. SS was diluted at 13.52%. DEPIA was diluted at 0.62%. Mineral composition and morphology analysis of VTLT used XRD and SEM, and assess the active component within the VTLT powder used the alkaline lynching method was employed. The stress activity index by employing the following specific formula. The activator matched with the highest activity index in each group was selected for the paste experiment, and heat of hydration used TAM air, and TJ used thermogravimetric analyzer. Fourth, result and discussion. 1. Thermal activation. We found that the particle morphology of VTLT not changed in the 550 to 950 degree interval, and the color of the tailings gradually changed from greenish green to earthy yellow. The mineral composition of tailings remained almost unchanged, and not only a small amount of metal was decomposed above 930 degree. Through the alkaline soluble lynch test, we confirmed that before and after calcination, the content of active silico aluminum element in the tailings powder didn't change significantly. The mortar test also shows that 7-day and 28-day compressive strength of specimen after doping calcination and before doping calcination, there is no significant increase or decrease. This suggests that use of thermal activation don't improve the activity index of VTLT mortar in this temperature range. 2. Chemical activation. The mortar test shows that the 7-day and 28-day compressive strength of 0.02% DEPIA are 36.1 MPa and 47.6 MPa respectively. Promote the hydration of VTLT cementitious materials. Its 7-day and 28-day activity index reached 78.3% and 85% respectively. There is no significant increase in the activity index of specimens at 7-day and 28-day for VTLT cementitious materials dropped with SS, and the dropped with CS and FGDG showed a decrease in the activity index. From heat of hydration of paste specimens, we found that the hydration amount of paste dropped with DEPIA for 7-day is significantly higher than that of paste dropped with others. DPIA has a stimulating effect on the cementitious materials consisting of VTIOT and reference cement, both in the term of early strains and later strains development, with the earth stimulating effect being more significant. From TJ, DTJ, and SEM, we found that dropped with different activators have some effect on hydration products formed by the cementitious material. The mass loss of the dropped with DPIA cementitious material were largest than others. The hydration products of paste with different activators are CSH, AFT, AFM act. 5. Conclusion. Calcined VTIOT at 550 to 950 degree. The macromorphology mineral phase, active silicate, and aluminum element of the tile didn't change significantly. Mechanical thermal activation failed to further improve the compressive strength and activity index of VTIOT motor. The mechanical chemical activation type of amount of activator have a greater effect on the compressive strength and the activity index of VTIOT motor. Dropped with 0.02% DPIA motor, 28 days compressive strength of 47.6 MPa and activity index of 85%. Compared with an added activator motor, the activity index greatly improved. Under the action of different activators, the hydration heat introduction period paste with VTIOT cementitious material is prolonged, and the hydration amount of paste dropped with DPIA for 7 days is significantly higher than others. The next is reference. That's all. Best regards. Thank you.
Okay, Chairman and Doctor, it's my presentation.
Okay, thank you very much, Mr. Nick Xiaoping Tian. Okay, we're still within the time limit. We have open for the question and answers from the floor. If you have any questions which we can direct to Mr. Nick, please do so. Any questions from the floor? Okay, while waiting for the questions, maybe I have one question from Mr. Nick.
Okay.
Okay. You mentioned about the heating process between 550 to 950 degrees Celsius, right?
Yes.
And then there's no significant changes on the structure of the molecules. So I just want to know whether if the rate of the heating can also affect the outcome of this molecule behavior. For instance, just now you mentioned 550 to 950 degrees Celsius will take about 1 hour. So let's say we shorten the time to 1 minute or 5 minutes to have a rapid increase of heat to the molecule. Would it change the result of your experiment? Thank you.
Okay. I do the heat with the temperature with 550 and to 950 degree. In fact, I do another test about the temperature. I use the TJ and test the raw material of VTIOT, and I found in the temperature of in the temperature of 950 to 500 to 900 degree 50 degree, it nearly not change the raw material raw VTLT raw VTLT. So it's a big problem. Maybe if I can improve the heat temperature degree, it maybe have another result. If I have another, because I adopt another method. Maybe it's not only the improve the temperature and adopt other method. Maybe it's have another result. So thermal activation method in the temperature this range is not improve the result, but maybe it's have more high temperature, and the other method is maybe okay. So this is not I need to do the next research. Yeah.
Right. Thank you, Mr. Nick.
Thank you.
Any other questions coming up for Mr. Nick? Maybe from the co-chair, Tonelli, any particular question? Still have time, about 3 minutes. Think. Okay, Mr. Nick,
Okay.
we can conclude our session now. We're
Okay.
thankful of your paper. We look forward to see you soon back in Sabah.
Okay, thank you.
And I wish you all the best. So we shall move on to the next presenter.
Okay, thank you. Thank you, Doctor.
Mr. Nick. So I think the next presenter would be Dr. Andrew Lim.
Yes, yeah, that's me.
Okay, Dr. Andrew. So your paper is in regard of undoped and is it correct?
And it's the one before.
Oh, okay, sorry. Assessment of pozzolanic reactivity of calcine spent bleaching of ash SBEA using strength activity index SAI, fraternity test and X-ray diffraction XRD. It's quite a mouthful there. Hope we get it all right. So authored by our none other Lim Chung Han and SS Binti Anwar. Okay. So all right. So the floor is yours, Dr. Lim.
Okay, thank you very much. Right. Okay. So my name's Dr. Andrew Lim Chung Han. I'm a lecturer at the Faculty of Engineering, UMS. So before I start my presentation, just apologies if you see I'm not looking directly at the screen. That's because I'm using two devices. I'm doing the presentation on my laptop, which doesn't have a webcam. So for you guys to look at me, I'm actually using a tablet. Yeah, so the tablet is beside the laptop. So that's why during the presentation, I'm not going to be looking directly at you. Okay. So, right. Okay. So my topic today is the assessment of pozzolanic reactivity of SBEA using three different methods, namely the strength activity index method, the Frattini test method, and X-ray diffraction method. Okay, so in essence, it's a very long title, but in essence, what I'm doing is I'm comparing 3 different methods of doing pozzolanic reactivity tests. Okay, so 3 different methods I'm assessing to find out how well these methods, the results from the methods correlate with each other. Okay, because all 3 methods are based on very different principles. Okay, which I will get to later during my course of my presentation. Okay, so it's basically comparing 3 different methods of doing pozzolanic reactivity tests. Okay, and the pozzolan sample that I'm using is this thing called spent bleaching earth SBEA. Okay, so hopefully this presentation is not going to take a very long time. Okay, so I'll try to wrap things up by 10 or 12 minutes. Right. So before I get into the thick of things, just a bit of introduction on the materials and on the methods itself. Right. So the pozzolan that I'm using for this purpose is spent bleaching earth ash. Okay. Even though this is not the main focus of my research, my research is more towards comparing the different methods. Okay. But this is the material that I'm using to compare the reactivity. So it's spent bleaching earth ash. It's basically waste material from the oil refinery process. Okay, so the original material is clay from the ground. It's a highly absorbent clay from the ground, which they use in refineries to refine palm oil. Okay, so as you can see, originally palm oil, once harvested, it's very dark red in color. So what they do then is they use this material, SBEA, to essentially suck up all the red color so that you end up with something more aesthetically appealing, okay? Light yellow, okay? So then what you end up with is basically this waste material, okay? So this material has previously been looked at by other researchers and also by myself, okay? So it has exhibited very good pozzolanic characteristics, okay? So it is a pozzolanic material. So for those of you who are not in construction materials discipline, so pozzolanic material is basically a material which you can use to replace cement. Okay, so that's the layman's term. Okay, although in truth it's a bit more complicated than that. But layman terms, pozzolanic material is basically a material that you can use to partially replace cement. Okay. So you use waste material to replace cement. So you're saving cost, you're saving environment, things like this. Okay. So that's the material. Okay. So next, I need to briefly also talk about what a pozzolanic reaction is as well. Okay. Because this will become relevant when I talk about the different methods which I'm going to use to assess the reaction. Okay. So basically, when you mix cement, okay, so this is cement here. So when you mix cement with water, you end up with what's known as calcium silicate hydrate, or in short, we just call it CSH in the industry, okay? CSH. This is what contributes, this is what gives strength to your concrete, this thing, okay? This is what gives strength to your concrete, okay? So when you mix cement with water, you end up with this, that gives strength to your concrete. But what you also end up with, you end up with a bit of calcium hydroxide within the mix, which doesn't do anything, okay? So this calcium hydroxide doesn't do anything, okay? So what you can do then is, you can introduce your pozzolanic material into the mix as well, and that will react with all this residual calcium hydroxide that is sitting there doing nothing. Okay, so it will react with calcium hydroxide to produce additional CSH. So basically, instead of just one portion of CSH, you now end up with 2 portions of CSH. So essentially, you should get more strength out of the whole mix. Okay, so that is the gist of what pozzolanic reaction is about. All right. Okay, so for the test, basically we are focusing on only 3 types of samples. Okay, so for the control sample, I'm using concrete. Okay, just your normal retail bag of concrete. Okay, so I'm using that for control. Test specimen 1 would be SBEA, the pozzolanic material itself. Test specimen 2 is SBA but treated. Okay, so treated SBA. So the way I'm treating it is very similar to what Nick did. So through calcination. Okay, so we expose it to high heat for 4 hours, 700 degrees Celsius, if not mistaken, for 4 hours. Okay, so as you can see, from black color, it turned into reddish orange color after being exposed to high heat for 4 hours. Okay, so those are the 3 different samples that I'm going to use to test out the 3 methods. Okay, so the first method that I'm going to use is this method. Okay, strength activity index method. Okay, so this method is basically based on strength. Okay, based on you're just doing you're assuming pozzolanic reactivity is related to mechanical strength. Okay, so we cast mortar cubes. So we cast mortar cubes. We cast control set and we cast a few set containing the SBA, pozzolanic materials. Okay, so the control sample would be set at 100% strength index, and then all the test materials, you would assess the strength in relation to the control sample strength, 100%. So if it's more than 100%, that means your specimen is stronger than the control sample. If it's less than 100%, that means it's not as strong as the control sample. Okay, so this is the first method I'm assessing the pozzolanic reactivity with. Okay, the strength activity index. So based on strength. The second method is very different compared to the first. So the second method is based on XRD. Okay, which is what Dr. Parimon, very similar to what Dr. Parimon did. Okay, earlier. Okay, so this method bases the pozzolanic reactivity on the morphology and, more importantly, the crystallinity of the material. Okay, so basically what we do is we also cast, for this test, we also cast our mortar samples, and then what we do is we take a small chunk out of the mortar sample, we crush it, and then we put it in this machine for it to generate the XRD diffractogram. Okay, which will tell us how crystalline the material is. Okay, and we will relate the crystallinity with the reactivity. So in essence, the higher the intensity, it should reflect higher reactivity as well, in essence lah. Okay, at least. So, and finally, the third method. So this is the third and final method that I'm going to use, which is what I call the chemical method. Okay, the Frattini test. So what this does is, so as you can remember, if you can remember what when I was going through the pozzolanic reactivity slides just now. Okay, SBA or pozzolans require the presence of calcium hydroxide to react with, okay, to produce this CSH paste. Okay, so what this test does is we artificially introduce calcium hydroxide. Okay, so we chemically produce some calcium hydroxide, and then we drop our pozzolanic material in there, mix it in to see whether this calcium hydroxide gets consumed or not. Okay, if it gets consumed, that means some pozzolanic reaction is happening. Okay, so by the end of the experiment, if you end up with less calcium hydroxide, that means you end up with a lot of pozzolanic reactivity. Okay, so this is what I call the artificial method lah, using some chemical trickery. Okay, so from this test, is essentially what we're looking for is the lower the residual calcium hydroxide that remains, you should get higher reactivity. Okay, so these are the 3 tests, okay, in theory. Okay, so now we can go to the results of all the 3 tests. Okay, so the first test, strength activity index. Okay, you can ignore the text on the left-hand side. Okay, we just look at the graph here. Okay, so the gray color is the control at 100%. Okay, so you can see the untreated pozzolan achieved an improvement of 36%. Yeah, so it's gone up by 130. So it's 136. So that means it's an improvement of 36% lah over the control. Okay, whereas the treated sample only improved by 29%. So this is for 7-day strength, by the way. Okay, if you look at 28-day strength, you get even more improvement. Okay, 84% for the untreated 73% for the treated. So what this is telling us is actually for this test, it's telling us that the untreated sample is the one that's giving us the best performance, not the treated one. So basically all the treatment that you're doing, the calcination, everything, actually, it doesn't give you that much improvement. You might as well not do it because you're getting more strength out of the untreated one. Okay, so that's the result for the SAI method. So next, I repeat essentially the same test, but using the XRD method. Okay, so the XRD method is telling me a slightly different story. Okay, because what the XRD method is telling me is, so if you look at the intensity, so right at the top, this graph, the top graph is the graph for the control sample. Okay, so not that much intense. So 1,767 is the intensity. The one in the middle, the graph in the middle, is for the untreated SBA. So you can see slightly higher, slightly elevated levels of intensity. And finally, the treated one, you get the highest intensity. Okay, so if you look at it in terms of intensity, it's the treated one that gives us the highest intensity and hence a better performance. Okay, so that's the XRD result. Okay, and finally, we go on to the chemical test, the Fratini test. Okay, so the Fratini test is giving us very similar results to the first test, the SAI one. Okay, so as you can see, this is the graph. So the blue line here is the control. Anything at the top is saying there's no consumption of calcium hydroxide, so nothing's happening. Okay, whereas if you go towards the bottom of the blue line, the more to the left, okay, the further left you go indicates the more reactivity. Okay, because that means because the x-axis is measuring the OH concentration remaining. Okay, so as you can see, this 3.6 here, that's the one that has the least amount of calcium hydroxide left. Okay, so that indicates highest reactivity here. Okay, this light blue color. Okay, and this light blue color corresponds to U15, which is the untreated SBA again. Okay, so this test is telling us the untreated SBA is giving us the best reactivity. Okay, so to conclude, what we're seeing here is the Fratini test and the SAI test. So the first and the third test are giving us very similar results. Okay, in other words, it's telling us that the treatment of the pozzolanic material is not actually giving us any benefit. However, the XRD test is telling us a slightly different story. Okay, it's telling us that the treated one is the one giving us better performance. Okay, so as you can see, between the three methods, there are some differences. Okay, between what results you can get. Okay, so yeah, so that's basically it. I think that concludes my presentation for today. And I think I'll hand the floor back to Mr. Chairman. Thank you.
Thank you, Dr. Lim. So we still have a lot of time actually. So I would like to open the floor for any questions, any ideas or recommendations in regard of this paper just presented. Everyone, anyone? Okay, while waiting for others, perhaps I can have one question for you, Dr. Lim.
Yep, sure.
Okay. I understand it is quite quite relevant to our industry, especially for the construction industry, because you're talking about cement mortar, right? Cement, in the sense of adding this pozzolanic material as additive.
Yeah.
It's not actually an alternative or replacement of cement, right? It's just an additive. Am I right?
Additive or partial replacement.
Partial,
Yeah.
but you cannot totally replace cement. Because
Cannot.
you still need to what the calcium hydroxide, something like that, to reactivate the process. Anyway, perhaps you can share with us the ratio of your SBEA composition in any of this concrete mix, whether that have any significant variation to the outcome of your result, especially in regard of the reactivity between the SBEA and your treated mix. If I can see in your conclusion, as of now, this SBEA have actually improved the concrete strength substantially. So whether the mix can be adjusted in order for you to achieve the most optimum increase of the capacity of the strength of the concrete in that sense. Doctor, thank you.
Yeah, that's a very good question, Engineer Amirul. Okay, so I forgot to preface my presentation just now. So the SAI method, so the strength activity index method, is actually performed based on an ASTM standard. Okay, there's actually a standard that governs how you do this test. Okay, so for that standard, what it's saying is we have to use a replacement level of 20%, so that everyone else in the world who uses this method replaces just a 20%, so that we can compare our results. So that the results are comparable. Correct. Okay. Yeah. So 20% is what I use for this test. But to answer your question, yes. From my other test, which is not covered here in this presentation, yes, there is actually an optimum level of replacement. If not mistaken, because I did not go through my notes before this presentation. If not mistaken, I think it's about 20 to 30% as well. That's the optimum level. If you go less, well, 20 to 30% is where you get the maximum strength. So which is why I call it the optimum level. If you put any more than 20, 30%, you actually get a reduction in strength. Anything less, you also get a reduction in strength. You don't achieve this high strength. Yeah. So obviously, because pozzolanic material, a lot of pozzolanic materials are actually waste material, right? So you want to be able to put as much in as you can so that you reduce the amount of cement you use. Yeah. But yeah, so unfortunately, there is a trade-off to be made here, because you want to put around 20 to 30% now. Anything more, the strength will go down.
All right.
Yeah. But that is for untreated SBEA. Yeah. There is actually another method of treatment, which I didn't cover here, which is by grinding. So making the particles finer. If you can make it finer, you can actually increase the amount of replacement as well. Yeah.
Most of this exposure to the reaction with the other chemical, right?
Right. Yes. Yeah.
Okay. Right. Good. Thank you so much. Any other questions from the floor?
Yeah, good morning.
Anyone? Yes.
I'm Nelly. Yeah,
Okay.
I just want to ask, regarding the SAI, is there a reason why the untreated SBA is higher than the treated SBA?
Okay. So in this, yes, yeah. So in this instance, the untreated SBEA, obviously, yeah, he has a higher strength, and the treated one lower strength, because there are research out there that indicates, because the way I do the treatment is using calcination. Yeah, calcination means you subject the pozzolan to high temperatures before you actually use it as a pozzolan. Okay, so that's the treatment I'm using. Now, when you try to improve the performance of pozzolans using calcination, you have to be careful with the temperature you use. Every pozzolan has an ideal temperature in which you activate it or you treat it with. Okay, certain pozzolans you're looking at about 500 degrees Celsius. some 700 degrees Celsius. If you go over this temperature, what actually happens is you reduce the reactivity of the pozzolan. So the temperature range is very important. So in this case, I probably used the wrong temperature because I only investigated one temperature, 700 degrees. I should have done one for 500. Maybe I should have done another one for 600. Then I may get an improvement in strength if I had done that. So to answer your question, I didn't go for the correct temperature, basically.
Okay, thank you very much.
Okay.
Thank you, Nelly. Any other questions, maybe on the floor? Okay. I think if there's none, I still have 1 minute. Okay, I think we can conclude this session with Dr. Lim. Thank you so much for your time and your paper. It was well presented and very informative too. And we can conclude our session with Dr. Lim and move on to the next paper. Thank you, Dr. Lim. All right, our next presenter will present the paper titled Undoped and was it Li lithium or lidop? Coral reef-like structures fabricated using immersion method. Is it lithium? Li? Correct?
It's lithium IR.
Okay, lithium. All right. Thank you.
Lithium.
So, okay, we welcome Professor, I suppose, Nur Amira.
No, I have no title yet.
Okay, Neman. Miss Nur Amira binti Lajahirin to present her paper on the subject of undoped and lithium dope nickel oxide coral reef-like structures fabricated using immersion method. Thank you. By all means, Mira, floor is yours.
Okay, first of all, Assalamualaikum and good morning to chairperson, speakers and audience. My name is Nur Amira binti Lajahirin. I have no title yet as I'm still study master in engineering at UMS. So I was about to present my paper titled Undoped and Lithium Doped Nickel Oxide Coral Reef-like structure fabricated using immersion method. So along with me working on this work is TS Dr. Nurfara Rianti Parimon from UMS, Associate Professor Muhammad Hafiz and Muhammad Firdaus Malik from UiTM Shah Alam, and also Muhammad Nur Afnan Uda from UMS. So, starting with the introduction, in the past few years, there has been a remarkable increase in the popularity of product made of silicon-based nanomaterial across the various industry due to their reliability and stability. However, researchers have been actively exploring alternative ways to replace silicon-based product that can perform as well as silicon-based product or even better. Among that alternative, they are often using metal oxide semiconductor, which have demonstrated a great thermal conductivity potential, chemical and environmental resistance, and dielectric strength. For example, in the application in electronic devices, sensor, capacitor, and semiconductor device. So basically, there are two types of metal oxide semiconductor, which are N-type and P-type. So moving to the content of our work, we are choosing nickel oxide, a P-type metal oxide semiconductor, as a precursor due to its unique properties. As you can see here, there are 6 properties. All right. For doping, we are using lithium. Why? Because previous research has proved that Adding dopant element into precursor sample can modify the conductivity of the sample. Popular metal that often used by researcher like zinc, mangan, chromium, and lithium and copper. Yeah, we choose lithium because lithium has high mobility, which means they can easily move through the material and have unique electrical property, where it can donate electron easily, allowing it to alter the conductivity and electronic structure of the semiconductor. So this work basically examine the lithium doped nickel oxide properties to be compared with the pure one, pure nickel oxide. To develop undoped nickel oxide and lithium nickel oxide sample, we started with the glass cleaning lah, because we deposited the sample on the glass substrate. We deposited nickel oxide solution through a sol gel spin coating method, which producing nickel oxide thin film. We continue the the process through the immersion method. Then we continue with the characterization. To be more detailed and nickel oxide deposition process, we use a mixture of nickel acetate, diethanolamine, and 2-methoxyethanol. This will act as a precursor, stabilizer, and also solvent lah, respectively, to form a thin film. So this is the process. While this picture represent the the growth of the nanostructure of both undoped and lithium doped nickel oxide. So this is the parameter of the experiment. For the samples characterization, we are using these 4 equipment to examine the properties of samples. So there are 4 properties that we use to examine the characteristic of this blood sample lah. First, we use FISEM, this one. We use XRD, UVVs, and also IV measurement. So moving to the result section, for morphological part from FISEM image, we can see here both undoped and lithium doped produce a nanosheet. Nanosheet is this thin layer ni lah. Then it's also produce a nanocoral reef, as you can see here, nanocoral. So from here we can see that the nanocoral is not uniform, so we cannot use this thickness to measure other properties. So we use nanosheet thickness to measure properties lah. So for other result like structural, optical, and electrical, I will conclude in the conclusion part. So for undoped and lithium nickel oxide structure was successfully synthesized using a sol gel immersion method. There are significant difference exist between both samples regarding to their properties. As I mentioned before, I use a nanosheet, the thickness of the nanosheet to run other properties lah. Alright. For morphological, I said before, the lithium doped nickel oxide is thicker than undoped nickel oxide sample. For structural properties, the average crystallite size for lithium is large than undoped one. This is the result lah. So for optical properties, I plot a top plot. This is the top plot. So we found that the the band gap of both sample falls within the maximum value of the general band gap of nickel oxide. This one. Lastly, for electrical properties, the conductivity of lithium is higher than the undoped sample. From here we can conclude the properties of nickel oxide could be improved with the cooperation of lithium as the dopant element. Further information about the result you can ask during the Q&A session, okay? As we're running off time. Okay. So this result promising in the optimization in certain application such as a smart window material that can change color and transparency in response to the apply voltage. So using the opportunity, we would like to express our gratitude to Ministry of Higher Education for the financial support through the grant and to the Nano Electronic Center at UiTM Shah Alam for providing us the laboratory facilities. That's all for me. Thank you.
Right, thank you, Ms. Noamira, the undergraduate or master, right, in UMS?
Yeah.
Okay, that was
Before
very,
that, I'm
yeah.
sorry for not using background provided because my computer not support that feature. Sorry.
Okay. All right. I think that take note for the host lah later. So, okay. Thank you for the paper. Any questions from the floor in regard of this subject? We still about have 5 minutes left. We can go for one or two questions. Anyone from the floor? Okay, maybe I have one question. Ms. Noamira, you mentioned about the result of your experiment that the conductivity of nickel oxide have increased from 40% to more than 50%. Correct? Huh? So whether the conductivity rate remain the same or varies in the event of change of temperature of the material. For example, I give you example. We have a high voltage cable, which consists of aluminum and steel, whether during operation it can goes up to 70 degrees temperature. So whether this temperature have any significant impact or variation to your conductivity that you have recorded, which is at 53%. Can it go lower or will be increased or how? Maybe you can just give some input on that, Ms. Noramira. Thank you.
So based on my research review, I not really run in that temperature difference. Sorry. So I believe that it may make the conductivity higher than the temperature room. Yeah.
So
Did
it
I
can.
answer your question?
You mean the conductivity can be increased if the
Yeah.
temperature goes up? Is that what you're saying? The one that you have run the experiment is at what temperature? Maybe just for
I run under the room temperature.
room temperature. All right, right. Okay. Thank you, Amira. Any questions?
IR, maybe I
Yes.
can answer for Amira's question.
Okay.
Actually, the sample is annual at 500 degrees C. Yeah, the experimental in temperature room. But the sample itself is anneal or calcine at 500 degrees C. But the problem is the sample is deposited or grows on the glass substrates. So the melting point of the glass substrate is maybe in 550. So we can't anneal higher than that, higher than 500 because of maybe the glass substrate will crack. So in future, I think if we use higher than 500, it may affect on the conductivity, because one other sample I have anneal at 600, so the conductivity is improved, enhanced on the conductivity. So maybe we can try for the sample to anneal at different annealing temperature. Thank you.
Thank you, Dr. Nafara. Okay, all right, any other questions from the floor? We have still 1 minute left, 1.5 minutes. Okay, if not, then I have one more question. Very interested subject. You mentioned about the nano sheet, right? What is the function of this nano sheet? Is this a platform for the activity chemical reaction to take place, or is just the function of it? I just want to know what is the function of this nano sheet.
So the function is the nano sheet. Actually, it can attend the adhesion of nanostructure and the glass substrate.
All right.
Yeah,
It's
because
intimate-
before this, Dr. Fararianti Parimon have run this kind of experiment where he ran on the nanosheet and without nanosheet. So she found out that the result is better using the thin film or nanosheet, or compared to without the nanosheet.
So it facilitates that the process. Okay. All right. Thank you so much, Amira. I think we have just concluded
You're
our.
welcome.
I think is it the last paper from the host? Thank you so much. So can I check with the host, UMS? Is it the last paper in this session?
Hi, Ramiro.
Yeah.
Okay, we have two more presenters, but they
Oh, I
are
see.
only videos, and the presenters are not with us today,
Oh, I see.
unfortunately. So we will just play the video, but I'm afraid we will not have any Q&A sessions.
Yeah. Just for you for sharing lah. Okay lah. So
Yes.
can start lah. I'm not sure what is the paper is about. Okay. All right.
Yeah.
So the next paper is about a review of nanotechnology applications in sustainable cementitious materials. So, who prepared this paper, or is prepared by Prof. Farid Abid, and the secretariat will play the videos lah, for us to watch and see lah. And any questions, perhaps you can write it down and send it to secretariat for them to convey to the paper honor paper of the paper. Thank you.
Hello, everybody. This is Professor Farid Abid from American University of Sharjah in the United Arab Emirates. Today, I will be talking about a review paper that was actually mainly developed by my postdoc, Dr. Hussein Hamada. It's about nanotechnology, the use of nanotechnology and its applications in sustainable cementitious materials. So we start with the introduction here. Two main points in the introduction. First one is the application of nanotechnology in the construction industry can solve numerous environmental issues by effectively utilizing large quantities of waste materials generated during construction. And nanotechnology can improve the workability, compressive, flexure, and tensile properties, mechanical properties, as well as the durability properties, such as the water absorption, chloride ion permeability, and shrinkage. The problem statement here that we're trying to actually state is that a substantial volume of waste materials remains unused, unutilized, and unrecycled, which in turn is contributing to the environmental challenges that we face in our life. So the main objectives of this review is actually to show the feasibility of the use of nanotechnology in reducing the harmful gases, especially CO2, that is harmful to the or carbon dioxide, harmful to the environment, thus enhancing their environmental aspect. To show the importance of nanotechnology in improving both mechanical properties and durability properties of the concrete. Before starting of the outcome of the literature review, let me just go over some statements from the literature review that we know, but it's good to go over them again. As you know, the production of 1 ton of cement leads to release of almost 0.75 to 1 ton of emissions of carbon dioxide into the atmosphere, causing climate change and environmental pollution. So the main idea is actually to convert what we use the conventional cement production from unavoidable CO2 to source to sink the CO2 and reduce its negative effect on the environment. One more statement here is that nanotechnology is known as an innovative approach focused on modifying the performance and behavior of materials at the nanoscale, usually between 1 to 100 nanometers. So changing the negative enthalpy, that's the use of nanofillers in the concrete actually will produce high system energy and nano-engineered concrete. So this process can also achieve significant environmental and sustainability benefit within the construction industry. The most widely used nanomaterials in construction include carbon nanotubes, nano CaCO3, nano titanium oxide, nano alumina oxide, and nano silica oxide. So I'm going to show you some outcomes of these lecture reviews. The first is the effect of using nanoclay on the properties of cement, mortar, and concrete. So in this table, actually, we summarize the top three of the many references that actually used a nanoclay cement content in weight of kilogram per cubic meter between 15 all the way to 27. So Mokhtar et al. Used 15 to 27 percentages of kilogram of nanoclay content added to a cement content of 450 kilogram per cubic meters. Their outcome actually and its effect on the concrete properties, they observed that the high pozzolanic activity and large surface area of nanoclay contribute to enhanced performance when added to concrete samples, in turn resulting in increased compressive flexure and tensile properties. Another study by Mihrabi actually also showed that the use of up to 9% of nanoclay in almost 350 kilogram per cubic meter cement content observed that owing to their microfilling ability and pozzolanic reactivity, they showed that the use of nanoclay leads to an increase in the density of concrete. In addition, the high pozzolanic reactivity and specific surface area of nanoclay can minimize the porosity and increase the density of the cement mortar. So nano fly ash can be prepared using a mechanical process that minimizes their particle sizes from micro to nano scale. In this graph, in this bar chart, you see that the effect of or different replacement ratios of or levels of fly ash and nano fly ash on the compressive strength. And you can see from here is that the use of 10% was the most optimum percentage in improving the compressive strength of concrete up to from I would say 60 to 85 megapascal, which is a huge. But then they noticed that, well, it can start decreasing. So the results showed that the 10% of nano fly ash or fly ash is more optimum to improve the compressive strength. Another outcome here is to show the effect of nano palm oil fuel ash or POFA on the cement, mortar, and concrete properties. Hamada et al., which is our postdoc here, actually showed or used up to 150 kilogram per cubic meter nano POFA content with cement content of up to 500 kilogram per cubic meters. They showed that the use of 30% nano POFA as a cement replacement has significant impact in improving the workability of concrete mixtures. Nano POFA led to increasing the compressive strength up to 58 megapascal, as well as improving the durability of concrete. The compressive strength also, by another study by Wee et al., who used up to 400 kilogram per cubic meter BOFA, nano BOFA, with cement content of 450 kilogram per cubic meters, they observed that the compressive strength increased with time due to creating further CSH gels. Consequently, the optimum proportion of nano BOFA is 30%, which should be used to get the best performance of concrete. So Hamada as the outlined a multi-step process for preparing nano eggshell powder, as shown in figure 2 here, the figure actually. So they outlined a multi-step process for preparing nano ESP, eggshells powder, involving heating the eggshells and mechanically crushing it. So as you can see here, heating oven up to 110, then mechanically crushing it. Then they investigated its use as a cement replacement, ranging from 0 to 5% of the total cement weight. Their finding revealed that the nano ESP exhibited a nanoparticle size of up to 524 nanometers with a high specific surface area. Another table showing the outcomes here is the effect of nanoslag on the properties of cement, mortar, and concrete. Sahob and Bera used quantities up to 40% of nanoslag content, kilogram per cubic meters, with cement content up to of 537 kilogram per cubic meters. They showed that the addition of 20% nanoslag as a cement replacement resulted in higher compressive strength compared to other concrete mixtures, with an increase of up to 17% compared to normal or controlled specimen without nanoslag. However, the compressive strength reduced gradually as a result of adding more than 20%. So kind of 20% was their optimum percentage. Sadawi et al. Also showed that the addition of nanoslag can increase the formation of products of CSH, thus resulting in an increase in the early age compressive strength of concrete. Abatidia et al. Also showed that the use of 22% of kilograms, per cubic meters nanoslag content with 450 cement content kilogram per cubic meters as well. The addition of nanoslag results in an increase in the density as well, up to 1.43%, and reduction in the porosity of oil and water absorption. This table also shows the effect of using nanoglass waste on the properties of cement mortar. As you can see here, most of the paper is about using the waste, and that is the target of the review actual paper, and at the nanoscale. So you can bring glass and then crush it and until you reach to a certain size at the nano level, and use it in the concrete mixes. So ICECON et al. Used up to 46 kilogram per cubic meters nanoglass content with cement content of 460 kilogram per cubic meters. They observed that the addition of nanoglass resulted in reducing the slump value by about 12% compared to the reference sample because of the shape and high specific surface area of nanoglass powder. Whereas the addition of 5% nanoglass powder led to an increase in the compressive strength of content of concrete from 12 megapascal to 21 meg, almost 80%. Amran also used the same percentage as Onaise, but he observed that the addition of nanoglass led to a reduction in the workability of concrete, increasing the nanoglass powder from 0 to 6%, enhancing the compressive flexure and tensile strength of the concrete mix. So as a general conclusion of these, I need to put, I don't need to increase the time, so there are many other results to share, but I believe here I will just go over the main point of the conclusion of these studies. So one of them is the addition of nanoclay and calcinated nanoclay can improve the performance of cement concrete and prove to be optimal materials due to their availability, pozzonic properties, high specific surface area, and cost effectiveness when compared to other materials. Both nanofly ash and nanobofa exhibit a high pozzolanic activity and possess a high specific surface area. Thus, utilizing them as partial cement replacement can lead to increased compressive strength and reduce water absorption. This is attributed to the additional production of CSH gels, which are crucial for enhancing the microstructure. Also, the addition of 2.5 to 5% of nano ESP eggshells powder can improve the mechanical properties and reduce the water absorption of concrete. And finally, the addition of nanoslag and nanoglass in a small amount can enhance the mechanical and durability properties of concrete, especially at later stages. So these are the main conclusion. I would like to thank you. These are some of the references that we used in our work, and thank you. If you have any questions. Hello, everybody. This is
Right. Thank you, Secretariat. So the next paper is about a concise introduction to the development of roller compacted concrete mixed design for Ningiri hydroelectric project. Paper presented by Jun Jianku.
Hi, Ramiro. Sorry, we have a bit of technical glitches. We are in the midst of sorting it out. Just give us a bit more time.
Okay.
A very good day for all audience. My name is Ku Chun Chen from Sound Instrument, student from UTHM. Now I'm working at Sound Instrument and the project is based at the Kelantan for the Nangri hydroelectric project. Now I would like to present my paper with a title of A Concise Introduction to the Development of RCC Mixed Design for the Nangri Hydroelectric Project. First of all, I would like to introduce about the RCC. It is same as the soil embankment. It involves the steps of 3mm layer were deposited by the dump truck, then leveled by scraper, and lastly consolidated by the passes of a vibratory roller. So why do we choose the RCC? Because of its advantages, which can be environmentally friendly and also cost effective. This is because of less cement is utilized for making the mixed design for the construction of RCC. That's why it could be effective for achieving the SDG, which is the hot topic now for all global around the world. RCC should be designed based on the feasibility study, which have been made for the Nangri hydroelectric main dam based on the situation, which is the site, is it applicable or not for construction of RCC based on the economic and also based on others factor. Now I would like to present the two factor which is mostly to be concerned, which is first one, availability of the large amount of the limestone near the earth surface and also have a good foundation aggregate near the dam site. That's why it can be applicable for using these natural resources for construction for RCC construction by using this aggregate which is available on the site which or near to the site, and also this can be benefit for the people, like it can reduce the risk of flooding and also can produce the clean and raw water for the cultivation. The purpose for me for doing this research because of this a few of challenges. First one, because of the mixed production play an important role in RCC dams construction, which is determining the all properties of RCC, which is start from the mixed design. That's why mixed design should be made properly based on the requirement. That's why various mixed design will be developed and identify all the properties based on the spec, and also the prospect of obtaining the suitable material could be challenging based on the site. That's why all the materials should be evaluated and also testing, and then based on the properties which is made from these natural resources, we can do some exercise of adjusting the mixed proportion to achieve a desirable final product. And also, last but not least, the trial placement should be concerned after all the mixed design have been developed to ensure the suitability and efficacy of the design mix prior to proper placement. The objective for this research is to evaluate the RCC material mix design and also to develop a RCC mix design protocol. Now we are moving to the methodology. So first of all, we have to start from sampling of RCC material to evaluate the RCC material, which are the aggregate, cement, fly ash, and mortar based on the spec. Firstly, for the first stage of RCC mix design, we should like evaluate the suitability of using the mix design, like the molding the RCC cylinder for the testing of direct tensile strength and also the compressive strength. And because of RCC is a zero slump concrete, that's why we should use the technology of measuring the slump for the zero slump concrete, like BB time, to determine the consistency and also can determine the density based on the test method. And also setting time is most concerning because this RCC is compacted layer by layer. That's why the setting time should be identified for the site construction. And then the alkali aggregate potential reaction also is the things that we should concern to determine the durability of the concrete. So after we have finished the first stage of RCC mix design, we will select one or more mix design that should be further studied. So in second stage, we will do the detailed study more on thermal properties, strength properties, and lift joint properties determination. Lastly, the selected mix design also should be trial placement before the proper placement, which could be inspect and evaluate based on the site production for the trial embankment to evaluate the permeability and also the in situ strength based on the site production. So currently we are doing the progress on the evaluation of the material like aggregate. So the process for now, we have identified the water absorption, and also the SSD for the aggregate group 1, group 2, and group 3. And we also have inspected the production of the aggregate like G1, G2 for the particle shape to inspect the consistency of the production of the aggregate and also should be compliant to the requirement. So this one is the continue for the G2 result for the particle shape. Then after we have evaluated the material, we are going to have a preliminary dry mix based on the aggregate, which is the compact aggregate that can be utilized for making the dry mix, which is the graded one. As you can see from here, here are the preliminary mix design from different mix design. What you can see from the table here, we got the VP time, the result for the VP time, density, the compressive strength, then direct tensile strength, and also the setting time. So as a result, from the preliminary mix design, got 5 mix design are selected for the next stage, which is the first stage of the mix design for the further study as highlighted in orange color. That's all for me. Thank you.
Building your business.
Okay, thank you, Secretariat. The next paper.
Amirul, we have no more paper.
Okay.
That's the end of our session.
All right. So I think I have to say thanks to all the presenter just now, and for the secretariat for giving us the opportunity to chair, and I also would like to thank Nelly to co-chair this session as well. And I think there will be evaluation on all the presenters, and one of them will be selected as the best presenter. May I check with the secretary? Shall we inform this through you directly, and you will announce, or how, or it can be done later?
Amirul, we will announce it at the closing ceremony
Okay.
of
All right.
this conference.
All right. So I will share the information to the secretary later. So again, I will return the one question for all the presenters now. I just wondering the word doping. Why do you choose the word doping? Sounds like a drug. Just wondering, any of the presenter here can answer that? When you say doping the material.
Yeah, Amirul,
Yes.
as far as I know, in materials, we just we use that terms
Okay.
add a little bit a percentage of apa, such as the metal. So another words we use is a composite.
Okay.
But that composite is just like 50-50. But for the doping,
Okay.
it's just a little. So
Oh,
I don't know.
I see.
Yeah, the percentage of doping is just 1%. Less
Oh,
than
okay.
1% we use doping.
Use doping. Oh, okay. That's really interesting. Because usually the word dope is a negative connotation. Anyway, it's good to know. So yeah, it's a new knowledge for every one of us here. Thank you so much. So
Yeah.
okay, I'll turn back to the secretariat, the floor, and I would like to thank to all of you again. Thank you so much.
All right, ladies and gentlemen, that is the end for our third parallel session. Thank you, Engineer Amirul Hisham Haji Ismail, Engineer Dr. Nelly Majain, and all presenters. We appreciate your effort for delivering insightful presentation. Now we will having our lunch break. Our next session will be start at 2 p.m. and the link can be obtained from the e-proceeding. Enjoy your lunch, be safe, and see you at 2 p.m. Thank you.
Thank you, everyone. Thank you, Amirul. Thank you very much.
Thank you.